Hey everybody, let's talk a little bit about conversions. So conversions are a topic you may have done some work on before, and they're important in this section where we talk about angular speed, because in the equation V equals R omega. So we've got the linear velocity here. We've got the radius here. And we've got the angular velocity here. And in order for this to work, first of all, angular velocity, for this equation to be true, angular velocity has to be in radians per unit time. And, a basic check of this would require that the units match up. So for instance, if this is inches and this is radians per second, then basically what I have is inches per second. So that's my linear velocity. But a lot of the problems you're going to get, there's a mismatch somewhere, right? Maybe the radius is in a different thing, or maybe the linear velocity comes in different units, but you actually want to have the answer come out in radians per minute or something like that. So conversions are going to come up in this process. So let's talk a little bit about conversions generally. And we'll start with some simple ones. We'll have distance and some time. So of course, to do a conversion, you have to know the relationship. So for instance, a mile is 5,280 feet. An hour is 60 minutes. Those are conversion facts, right? One thing is equal to the other. It's just a way of saying the same thing, a different way of saying the same thing. Also, 1 foot is 12 inches and 1 minute is 60 seconds. So let's say we wanted to know 3.2 miles is how many feet. Well, the first way I want to show you, just to remind ourselves about proportional reasoning, because this is really all that a conversion is a proportional reasoning problem, right? Where I have 1 mile is 5,280 feet. So therefore 3.2 miles would be equal to how many feet, right? And to solve this problem, we can just multiply diagonally and divide by the other number. That's a basic technique for solving proportional statements. So in other words, I'm going to do 3.2 times 5,280 and divide it by 1, which of course divided by 1 really doesn't do anything. So it's really just 3.2 times 5,280. My trusty handy calculator here. 16,896. Now, a proportional setup is not what I would recommend for conversions, especially if we're talking about dual unit conversions, where I have something like 26 miles per hour. This is actually 26 miles for every 1 hour. And what I'm going to show you next is a fractional technique, which is called dimensional analysis. This is used in chemistry, a lot of places where you have a lot of conversions, nursing. I'm going to leave my conversions there because I'll need those. But let's say I identify in my problem that I need to go from miles per hour. We'll stick with the 26 miles per hour. And I want to convert that into inches per second. Okay, so I'm going to need both of these, and I'm going to need both of these because I'm starting in miles, but I need to get to inches. I'm starting in hours, I need to get to seconds. So what I would do is start with the fraction that I have to convert, and I'm going to multiply by a series of fractions to make this conversion happen. Now, I'm utilizing a property of multiplying in fractions where if I have diagonal units that are the same or diagonal factors that are the same, I can cross them out. So 1 mile is 5,280 feet. 1 foot is 12 inches. And what I'm looking for here, the way I know I've set this up right, is that this crosses out diagonally. So the feet, the miles all cross out. What's left is the unit of inches. So at this point, I've converted my miles per hour into inches per hour. Okay, I got to go a little bit further here. Times. So hours need to get canceled. That means hours need to be on the top, minutes on the bottom, minutes on the top, seconds on the bottom. Now I'm going to put my numbers in. 1 hour is 60 minutes. 1 minute is 60 seconds. I'm going to cross out the things that I have in common diagonally because that helps me see that I did this correctly and I'm ready to go. So on the top, it's 26 times 5,280 times 12 times 1 times 1, which doesn't mean anything. So a really big number, 1647360 over 1 times 1 times 1 times 60 times 60, 3,600, dividing by 3,600 to finish it, 457.6. Units on top, inches, units on the bottom, seconds. So this is 457.6 inches per second. That's what 26 miles per hour translates into. So that's a basic conversion approach using fractions. The key is to bring the fact into a fraction that you're going to multiply. And the way you know who's on top and who's on bottom is by looking diagonally to see about that cancellation, that simplification that you're looking for. Okay, so that's the basic technique. Let me give you a problem for you to practice. So let's say we'll use the same figures with meters, with miles and feet and things. Let's say we want to convert 30 inches per minute, and I want to make that into feet per second. Okay, go ahead and press pause and try it out for yourself. And then when you unpause it, we'll lay it out. So we've got 30 inches per minute times, I need to get rid of the inches, so I'll put it on the bottom, feet goes on the top, it's 1 foot is 12 inches, and I need to convert minutes on the top, seconds on the bottom, 1 minute, 60 seconds, and we're set. I do want to do this part, inches is gone, minutes is gone. That's essentially my quality verification that I've done this right, is to look and see that I've eliminated the units that I don't want, and I still have the units that I do want. 12 times 60 is 720. So this turns out to be whatever 30 divided by 720 is, 0.41666666. Sorry, 0.041. And of course, there would probably be some rounding instructions in there to guide me in where I'm going to round this. So that's conversions.